Okay, so as we're looking at what you were doing, so this is what I'm looking at. So I can actually see, you know, which groups are writing things down. And I know one group had some technical difficulties, and I totally get it. So just so you know, when we're doing these, make sure that and I want you to be able to practice this for the test, because remember, everything you do on the test, you have to show me your work. If you just give me an answer, then that tells me that you're probably guessing, or maybe you're really good at doing it in your head. But I want to see the process. I want to see what your brain is doing and how you're processing the whole thing. So this one, so I did two groups had the same questions, and then all four groups of these kind, and then all four groups had the exact same question for the compound and continuous. So I wanted just to kind of make sure that you guys are all on the same page as far as understanding what the process is. So on this one, I see what you did is you crossed out the base, and hopefully you understood that little hat is an exponent. So you crossed out the base, and then it's a matter of, I don't know why that's so big. It's a matter of just setting up the two exponents to equal each other and then solving from there. So 101 minus 5 is 96. 96 divided by 2 is 48, and then you're done. But if this was on a test, I'd take points off, because I want to know, how did you do it? You just wrote an answer. I want to know, how did you do it? So just remember, what I'm looking for is, how are you doing it on the test? What's the process going through your brain on how you solve these? And then this one, I wanted to point out, you actually don't even need to square root both sides. This is the rule that says if your exponents are the same, your bases are equal to each other. Okay, so yes, this isn't incorrect as far as square rooting both sides, but you don't even have to do that, because of the rule that says if my exponents are the same, then my bases are also the same. And then again, what I'm looking for on the test, so I can actually see what you're doing, is your two-step process. Right, so you're going to subtract 5, so you get negative x equals negative 19, and then dividing by negative 1. So what this does is it allows me to look at your process to make sure that, yes, your process is correct. And if you're going into the next class, the Math 1325, which is business calculus, the biggest thing that students struggle with is just the basic algebra. I was shocked, and this semester seems to be very it's across the board, and every business calculus teacher that I've talked to has said the same thing. Their basic algebra skills are terrible, and so we want to make sure that your basic algebra skills are on point, so that when you do go to the next level, you'll do fine. Okay, so any questions on either of those two? And if you didn't have them, that's okay. I'm going to go over the ones that you did have. So I believe, yeah, so this one, this is one that we did. Another one where your bases are the same. And so that means the exponents are the same. So you can see what they did here is they did x squared minus x minus 42. And the way that they got the minus 42 is because when your bases are the same, your exponents are the same. So all they did is they brought the 42 over, which is what you need to do to solve for a quadratic. And then they factored. What do you multiply to get a negative 42 and add to get a negative 1? So this step right here, just so you know, whichever group this was group 2. This step right here was kind of unnecessary. Because you don't have a number in front of your x squared, you really don't need to split up this middle term. So this would be x plus 6, x minus 7, and then when you set it to 0, you get your negative 6 and negative 7. Okay? So this is going to be one that you definitely want to know how to do, because you will see this one again. Okay, and then this one, the second one, looks like you didn't quite get to it. Again, exponents are the same, which just means your bases are the same. And this is the exact same one. So we get x equals 19, I believe it was. Yeah, is that right? Yeah, x is 19. Okay, so those two were the two kinds. So room 3 and room 4 had the exact same ones. So let me go to this question. So I know in room 1, you wrote, oh darn, you wrote the formulas, which is perfect. So these two formulas you're going to see again in 3.2. The only difference is we're going to add another layer, and instead of just finding the total amount, the ending amount, you're going to find the time, or you're going to find the rate. So what we're going to learn today, you're going to be able to do that, be able to solve for the variable. Okay, so being able to plug it in. Now, this is another one where if on the test you don't show me the formula, I'm gonna take points off. I have to know which formula did you use in order to get your answer. Okay, and then once you write your formula down and where all the values go, then you can use your calculator, and that I'm totally okay with. It's just 10,000 times e raised to the 0.0395 times 12, and then you get your answer of 16,069. Is that, excuse me, 0.06. Okay, now remember we talked about making sure that your answers make sense. So anytime you're doing a continuous compound interest and another one that has the exact same values as your continuous compound interest, your answers should be very, very similar. If, for instance, let's say on the second one, let's say I got, 36,000, then I would know, okay, something's wrong. Something is desperately wrong, because these two answers should be the same. Whenever you're dealing with E, it's heading towards that 2.78. So when it says continuously, that doesn't mean that your interest is growing continuously. It just means that you're getting paid continuously, and it's going to head towards a peak. So it's not going to go past a certain amount. Okay, so it's not like you're going to, get billions of dollars because you have compound continuously interest. It just heads to a certain amount. Okay, and then it'll flatten out. So with this one, with your compounded quarterly, and again, if this was a test, yes, you showed me the formula, but you didn't tell me where the different values go in. So on a test, it would have to look like this. You show me the formula, and then you show me what values you plugged in where. And because it's quarterly, your number of compounds is 4, and then 4 times 12. Now you have the right information so that I can give you full credit. So that's what I really want to emphasize is on this next test, when you turn in your homework, you have to show me what you how you calculated it. And then for this one, it's always a challenge because it's order of operations. And some people are really good with putting in parentheses where they belong in your calculator, and some people are terrible at it. So your calculator will only calculate based on how you input the numbers. It doesn't know order of operation. It just does it the way you input it. So you have to do the order of operation as you go. So with this one, I always get my exponent first. So 4 times 12 is 48. So I always get this number first. And then I go to the 0.0395 divided by 4, and then I add 1, and then I raise it to 48, and then I multiply by 10,000. So 16,026.76 is the correct answer. But again, if this was the test, I want to know where you put your values in. Okay, so really practice on the calculator that you're going to use for your test. Don't just bounce around and, you know, let a computer do it for you. Know how to use your particular calculator. Okay. So any questions on any of those?
Miss Manchester, I had a quick question on the first slide. For the second question, yeah, for that one, I know like that we got 19 because of the rule of setting it to, but like if you were to factor it, you would also get x equals 3, right? Like how do you know you aren't missing?
So this one can't be factored because it's just x to the first power. The one, let's see, the one that can be factored was this one, because it's x squared. So the only time you can factor is if it has an x squared in your original problem.
I think she's saying like if you distribute the exponent of 2 across the
Let me get to the right.
problem, and then you factor each side. Like if you did the 2 squared, the 5, and the x.
Well, okay, so if you're going to do that, then you'd have to do x plus 5 times x plus 5, right? Because that's what x plus 5 squared means. So you'd have to FOIL, which would become x squared plus 10x plus 25. Is that what you're talking about?
Yes, ma'am.
Okay. And then if I did the same thing over here, this one would be 2x minus 14 times 2x minus 14. So what you're creating is something that is way more work than you need it to be. So 28 and 28 is 56x plus 14 squared is 196. So do you see how you're creating way more work than you need?
Yes, ma'am. I just like, do we just ignore that there's like another answer?
Ignore it. How? Well, but the other answer isn't necessarily correct. So let's see. Let me see what this. Yeah, because I know that what you're doing is you're creating way more work than you need to. And then 196 minus 25.
I mean, I guess just in terms of like tests for the same situation, would you only want this one answer and that would be the correct answer?
Yeah. Yep.
Okay, then
yeah.
never mind.
Because see, if you keep going, it's going to be real hard to find that x is 19. Because you're going to, if you factor or if you use the quadratic formula, it would be, yeah. Interesting. I've never, it's because of this rule. And that's what I love about math is always about making sure that you have the least resistance going into finding the answer. And with math, there is only one answer. So if I kept going with this, I won't, but if I kept going with this, you'd probably end up with an extraneous answer. So then you would have to plug it back in and make sure that this side equals this side. So and sometimes that happens where you get an answer that won't fit the scenario. So you definitely don't want to do that. I'm going to clear it. Okay. All right. So we're going to move into logarithms. Oh, one thing I wanted to bring up, I did send out an announcement, I don't know, last week, I think it was, or a few days ago. Anyway, this is the project. This is a car buying activity, and you will understand fully that how to find the answer once we get into 3.4, but I wanted to give it to you so that you can start working on it. And this is a car buying activity. This is a homework problem, but it's also extra credit for test 3. So it kind of plays double duty. So the extra credit is you get 5%, not points, but 5% added onto your test 3. So for instance, if you get an 85 on test 3, doing this project will boost your grade to 90%. But it's also a homework. So make sure that you do this. This is not due until December 4th. So that's the day that the section 3.4 is due. So I'm not expecting you to get it done now because you don't have all the information that you need to be able to answer this particular question right here. What is your monthly payment? In section 3.4, you'll know how to find your monthly payments. Okay, but you can start doing your research. What car you want, how much is the car going to cost, what's 10% of that. You can start researching what interest rates are on cars, and then how long do you want to pay on this car. And then so you can start getting some information. The only part that you won't be able to do yet is this: what's your monthly, what's your total, and what's your interest. But the rest of it you'll be able to. Okay, so I wanted to make sure that you are aware of that. So that is in module, it's in this module. So you will print it, you're gonna have to print it, and then you'll fill it out, and then you'll scan it and send it back to me as an assignment, okay? And then I will add the percentage back onto your test, okay? All right, so what we're going to do today is what's called log functions. So I'm going to start with this little PowerPoint that I put together, because logs, the short term is logs. Logarithms, those are called logarithmic functions, and all they are is an exponent. It's just an exponent in disguise. That's it. And if you can wrap your brain around that, it makes logs so much easier. So a log is what I call an exponent in disguise. So if you notice, if you see here, you have b raised to the x equals y. Okay, so this is just a general, this is exponent form, right? Any base raised to an exponent equals a value. Well, a log is just that exponential function rearranged. So log is written as log base b, and you can think of it as in the basement, so it's always going to be dropped, of whatever your total is equals the exponent. So that's where I say a log is an exponent, because this exponent is sitting right here. So when you see the term log, your answer is the exponent. Every time the answer is the exponent, okay? So it's just an exponent in disguise. That's how you're gonna, come on, over here. That's how you're going to think of it. Okay, so you're gonna write each exponential function as a log function. Okay, so here's our first one. So what I want you to do is I want you to, on a piece of paper, because that's how you're going to get really good at this. Look at your exponential function and go, okay, my base is 4. So you're going to start with the term you're going to start with the term log. My base is 4. My answer is 16, and my exponent is 2. So it's just an exponential function rearranged in a different order as a log function, but they're exactly the same thing. They are saying the exact same thing. So the way you would read this is log base 4 of 16 equals 2. Log base 4 of 16 equals 2. It's the exact same thing as 4 raised to the second power equals 16. Okay, they're exactly the same thing. There's no difference between any of them. Okay, and there it is. Okay, So a log is just an exponent. That's all. That's your mantra that you're going to put in your head. A log is an exponent. Okay. Any questions so far? Okay, so see if you can write this one before I show the answer. So your base is 3, your total is 81, and the exponent is 4. So it's log base 3 of 81 equals 4. Right now, you should be able to go back and forth. You should be able to take a log and write it as an exponent. You should be able to take an exponent and write it as a log. So this one, my base is 5. My total is 125. And my exponent is 3. Okay. All right, so we're gonna go through a few of these quickly. So this one we haven't talked a lot about fractional exponents, and we are going to jump into them now. But a fractional exponent is just another way to write a radical. And we've talked a little bit about, you know, what an index is, what a radicand is, what an exponent is. But whenever you see an exponential function right here, just know that the minute I see that, it's actually written, it's just another way to write the square root of 36. So remember, your index is here. This exponent is here. And so the square root of 36 is 6. Which means your base is 36. So see, now it's a little bit different. So log base 36 of 6 equals the exponent 1/2. Okay, and we're going to do a lot more of the fractional exponents. I don't know how you erase this. How in the world did I do that? Oh, there it is. Huh. Okay. All right, so here's our negative exponent, right? So it doesn't matter how we write it, what exponent we use. The writing it as a log is exactly the same way. My base is 2, my total is 1/8, and my exponent is -3. So that written as a log, my base is 2, my total is 1/8, and my exponent is -3. Okay, so a couple more. 10 to the 4th power is 10,000. So your base is 10, your total is a 10,000, and your exponent is 4. Now, on your calculator, you notice there's no base here. On your calculator, when you see the term log, so everyone make sure that you know where your log button is on your calculator, LOG. That is base 10. So your calculator only has one base, and I will show you a formula where you can change any value to any base. But when there is no exponent, or I'm sorry, when there's no base there, just remember that it's base 10. Every time it's base 10. Okay, otherwise it'll show a base. So this is anything to the 0 power. So remember, an exponent of 0 always equals 1. So this is log base 25 of the total 1 is the exponent 0. Okay, so the more you do these and the more you switch them back and forth, the easier it's going to be for you. Okay, now the reason why we do these is because sometimes it makes it easier to solve. So there's your exponential function. Okay, 2 raised to some exponent equals 8. As a log, 2 raised to some exponent, so 2 raised to some exponent equals 8. So what does your x equal? Well, now you have 2 different ways to solve this. You can say 2 raised to the variable x is the same as 2 cubed. So my x equals 3. So this is what we just did, right? As long as your bases are the same, then our exponents are equal to each other. Okay, we just solved that. With a log function, 2 raised to what power gives me 8? So x equals 3 because 2 raised to the third power gives me 8. Okay, so you can solve them, and you can go back and forth between the two of them to be able to solve. Okay, so now this one, we're looking for our base. Okay, we're looking for the base. So something raised to the third power gives me 125. So I can write this, right, as x raised to the third power gives me 5 raised to the third power. So this goes back to that rule we just did. If our exponents are the same, our bases are the same. So x equals 5. Okay, as a log, if you see it as a log base x of the total 125 equals 3. So this is where, and you can do it with both of them, this is where you can rewrite this as an exponent and be able to solve it very easily. So sometimes you're going to get something written as an exponential function. Sometimes you're going to have it written as a log function, and you have to be able to solve for both of those. Okay. So 4 raised to the negative 2 equals the total. So you can see in all three of these, we're asking 3 different questions. The first one, we asked, what's our exponent? The second one, we asked, what's our base? And the third one, we're asking, what's our total? So this one is, if it's written as a log, is log base 4 of something equals negative 2. So again, if you're given it in this setting, now you can solve it. So it's 1 over 4 squared, which is 1 over 16. Okay, so the idea is, can you look at a log and realize, oh, that's just an exponent in disguise. I'm just going to rearrange it so that I can solve it with the way that you know how to solve exponential functions. Okay, and then again, now we're back to solving for the x. That written as a log. Okay. So what would our x be? What would x equal on this one? Or this one? Don't think too hard. X to what power? Do you guys all leave me? Come on, I need an answer. Somebody. Thank you, Sophia. Yes, 1. So x 100 to the first power is 100, and then log base 100 of 100 is going to equal 1 also. So both of these are saying the exact same thing. Okay, and then 12,000 to 0 is x. And so because we know anything to the 0 power is going to be 1. So it's always going to be 1 when it is in that setting. Okay. And then now we have another fractional, I'm sorry, negative exponent. So what base gives us 1/27th when we raise it to the negative 3? So this one would be log base x of 127 equals negative 3. So again, can you rearrange it to be able to answer it? So if you had x to the negative 3 and you have 3 to the negative 3, that actually equals 1 over 27. So my x is 3. Okay, because 3 to the negative 3 gives me 1/27. Okay, so that's your basics of logs. Now we have just properties of logs, and we're going to do this real quick. So properties of logs just means, you know, basic properties that happen with all kinds of, with every log that has a basic property. So anytime you have log of 1, so again, common log is base 10. So that's what it equals. 10 raised to the 0 power equals 1. So if there is no base, it's base 10. It's kind of like the same idea as when you have square root. If there's no index, it's a 2. If you have just x and there's no number in front, it's a 1. So a common log is always base 10. So this one, and again, all I'm doing is I'm taking a log and I'm rewriting it as an exponent. So 10, because I have no base, 10 raised to the first power gives me 10. If you notice here, now this is why we do logs, because logs and exponents are inverses of each other. They undo each other, okay? So log base 10 raised to the x power. So remember, what it's saying is a log is an exponent. So this is saying, what is the exponent on 10 that gives me 10 raised to the x? It's just x. So look how I rewrote it as an exponent. 10 raised to the x power. So here's my 10 raised to the x power gives me 10 raised to the x. So it's literally, they cancel each other. That's the beauty of having base 10 and log base 10. So same thing here. This is my base 10 raised to the log. Those cancel each other. All I have left is x. So they undo each other. That's what it means to have an inverse operation. They always undo each other. Okay, so this is just more general, same exact scenarios as base 10, but now it's just if you have any base. So any base raised to the 0 power gives me 1. Any base raised to the first power gives me that base. The log base b of b raised to the x, these cancel each other. All I have left is x. And then b raised, this is up here, b raised to log base b, those also cancel each other. So all we have is x. Okay, so there's just some real basic rules and properties of logs that you have that just makes your life easier as far as how to do it. Okay, so that's log, that's log on your calculator. Now we're going to look at ln. And so ln is your natural log. Or it could be written, oh, not like that, sorry. Or it could be written as ln like that. So it looks like a 1 in the end, but it's actually an L and an N. So make sure you know where that button is on your calculator. It should be right around the log button. So ln is the opposite of E. They undo each other, okay? So that's super important. As long as you have an ln, that's actually E. So this is actually written as E raised to the 0 power gives me 1. Okay. So anytime you see the term ln, you know that it is power, gives me E, makes sense. So these are exactly the same types of properties as the log. And then here's where we love ln. ln cancels E. They undo each other. So all you have left is x. Same thing here. E raised to the ln, those cancel each other. All I have left is x. Okay, and you're going to see how these will work in a function. Okay, so these are just practice. So what I want you to do is I want you to, on your calculator, just make sure that when you hit ln5, and then make sure you close the parentheses, you get 1.609, and then I rounded it to 1.61. Okay, I want to make sure that you know how to use your calculator correctly, because the Casios, it's opposite. That's why I don't like Casios, because they make you input it opposite what the Texas Instruments do. Okay, so this is just practicing. Type in ln 30. Do you get out 3.401197? And then I rounded it to 4012. And this is where you need to be really careful on My Math Lab to look and see where you're supposed to round to. And then this is how it's written. It's the base e, because it's ln, so e raised to the 1.61 equals 5. So remember, this is the exponent. Your answer is the exponent. Same thing as a log. It's just called a natural log. And then ln of e equals 1, so that's e to the first power. E to the 0 power is 1. So these are exactly the same things as a log property. Okay, and this again, these cancel each other. So all we have left is 4. And then again, e raised to the ln cancels each other. So all we have left is 7x. Okay, any questions so far? With logs, it's a matter of...
Yeah, I have a question.
Yeah, go ahead.
On the last one, if you could go back, you said that of course E and ln would cross out, but where would you get the 7 from?
Well, that's just part of the problem
Oh.
right there. So those just cancel. So what's left is the 7x.
Okay. And why would
Okay.
why would it be called natural logarithms?
Because it's the inverse. So you know how e is, how e is the natural number?
Yeah.
Right? We learned about that on Monday or Tuesday, whatever day it was, Tuesday. And e is an irrational number. It equals 2.781 and it keeps on going forever. So it's a natural number because it is used in nature with growth and decay. So ln is the natural log. So because e is a special number, it needs its own special logarithm.
Okay.
Okay.
Thank you.
All right, so let's just try a couple and then we'll get in. You're welcome. We'll get into the worksheet and the types of problems that you're going to see in your My Math Lab. Okay, so you're going to get something like this. Log base 2 of 32. So this is where I want you to be able to rearrange it and go, okay, this is saying 2 raised to what power equals 32. Okay, 2 raised to what power equals 32. Can you mute yourself, Tiba? Thank you. Okay, so 2 raised to what power equals 32? So you can either just figure it out, 2 times 2 times 2 times 2 times 2, or you can write 32 as 2 to the 5th, and so your x equals 5. You have the same base, which means your exponents are equal to each other. So when you see this, you need to know what it's asking for. This is saying, find the exponent onto that gives you 32. Or just rewrite it. 2 to what power gives me 32. Okay, that's literally what it's asking, is 2 raised to what power gives me 32. That's okay, Tiba. It happens. I always go the opposite way. I never know I'm muted. Okay, so it's a matter of, all right, maybe you've seen logs before, maybe you haven't. So you have to train yourself to look at that. And remember, a log is an exponent. It's asking for the exponent on base 2 that gives me 32. Okay, let's try another one. How about that one? Anyone have an answer for me? The key is right here. You have ln and e together. Those cancel each other. So all you have left is 6. Okay, now if you aren't understanding what this is saying, because it's natural log, this is saying e to what power gives me e to the 6th power? Well, my bases are the same, so my exponent has to be 6. That's literally what it's saying. E to what power gives me e to the 6th? Well, instead of going through all of that, I know that ln and e cancel each other. Okay. All right. So what I'm going to do is get out of here. And we're going to go back to our OneNote. So on our OneNote, we kind of walk through some of the process. Oh, you know what? It's 12 o'clock already. I wasn't even paying attention to the time. So we're gonna jump back in here. Come back at 12:15, and we'll jump back in here, and I'll show you the problems that you're going to see in my math lab and how to work with the logs. Okay, so come back at 12:15.
Miss Manchester, I have a question.
Sure.
Actually, I was on one of your slides.
Okay, so before we get started, we still have a minute here. Is there anyone that has any questions so far about what we're looking at? I think it'll all start making sense. I'm freezing. I think it'll all start making sense when we start doing some of the problems that you'll see. So anybody have anything? Douglas, good to see you. At least you made it.
Yeah, Miss, can you go back to the general logs, because I didn't get it down. I want to take a picture of it so I can write it down.
Okay, yeah, and these are all in the OneNote. I'll show you where it is in the OneNote. Let's see, where is it? General log, right here, these ones. Is that what you're looking at? Let me make sure it shows.
Okay, I got them. Thank you.
Okay, you're welcome. And then just so you know, these are, if you go to the top, so again, we're in Math 1324. Homework 17 is the logarithmic functions. If you go up here, the green one, that's that PowerPoint I was just looking at. So you guys can have access to that, so you can look at it again if you ever need to. Okay. Okay, so what I did is I already started filling these in because we've already talked about it, right? Inverse of addition is subtraction. Inverse of multiplication is division. And inverse just means opposite. That's all it means. It's the opposite. One undoes the other. So like with addition, if you had 4 minus 4, it takes us back to 0. If you had 4 divided by 4, it takes us back to 1. So it always takes us back to the very basics. The squared terms, so if you had, 3 squared, what undoes that is if you square root it, remember that undoes that. So it comes back to our base. And then same thing with a cube. If you had, 5 to the 3rd power and you wanted to undo that, you would just cube root it. So what's nice about it is your answer is always right there. That tells you what the root is. So if you had the cube root of 5 cubed, this undoes this, and it comes back to your base. So whatever your exponent is, that's what's going to undo whatever root that is. That's what's going to undo it. And then, which brings us to our exponential functions. So our the exponential functions, b raised to the x. So remember, b just represents your base, whatever the base is, it doesn't matter. The inverse is log of whatever that base is. So if I had 5 raised to the x, the inverse of that is log base 5 of 5x gives me x, because again, that undoes that. Okay, and then the inverse of the natural number e. So you have e raised to the x. If I had ln of e raised to the x, again, those cancel each other. It brings me back to my base. Okay, so that's the basic premise of log functions. Logs are just exponents. It's the inverse operation. So some of the things that you're going to have to do in your MyMathLab. This is saying it's giving it to you in log form. They want you to write it in exponential form. So your base is 4. Your base is 4. This is your exponent. This is the total. So you could literally look at it this way. I'm gonna mark it all up for you. This is the base. This is my exponent. And this is my total. So it's just a rearrangement. That's all it is. It's just a rearrangement of your function. So my base is A, my exponent is C, and my total is B. So you just rearrange it. Okay, and then this one, because it's ln, my base is E, my exponent is D, and my total is T. Okay, so that's all you're doing with these is they're giving it to you in log form. You have to write it in exponential form. Okay, everyone okay with that? And you'll get comfortable with it. You just have to do it. That's where the practice comes in. Okay, and then example 2, it says write each one in log form. So it's log base 2 of 1/8 equals -3. So again, this is my base. This is the exponent. So a log is an exponent. And this is the total. Okay. So log of f, the total w, is the exponent h. And then the minute you see e, you know that you're dealing with the natural log. So ln of the total equals my exponent. So the ln is the indicator that your base is e. You don't have to write the base. ln is base e. Okay. All right, so we're good there. Just rearrange them. That's all you got to do. Okay. Being able to use your calculator or without the use of a calculator. So sometimes it wants you to use your calculator, sometimes it doesn't. So this is where your calculator has to have a log and an ln key. You cannot get through these next, well, till the end of the semester, you cannot get through it without a log and a ln key in your calculator. So if you don't have it, you need to go get it. And again, on the Northwest Vista campus, if you go into Juniper Hall, into the math labs, they have calculators available for you. All you have to do is have a student ID and they will loan them to you. Okay, so if you do this without a calculator, look, log and 12 cancel. My answer is, oh, sorry, I'm getting ahead of myself. Base 12 gives me a total of 12. In other words, what's the exponent on 12 that gives me 12? It's 1. Right? So if that's confusing to you, rewrite it. 12 to what power gives me 12? And that's completely okay. If you want to rewrite the log as an exponent, do that and then you can solve it. Okay, this is one I was going to cancel. So ln and e cancels. So all that's left is 5x plus 7. E and ln cancel. So all that's left is x squared plus 4. Okay. Now this one I put base 10, but remember I can write it as this This is the common log. This is the other way to write this. I put base 10 to remind you that when there isn't a base there, it's actually base 10. And these are so easy. If you have a multiple of 10, just count the zeros, because 10 raised to the 6th power is a 1 with 6 zeros. It's the same thing. So anytime, and this is one that there's a question on your My Math Lab, just count the zeros, you'll be good to go. That's your exponent. Okay, all right, I'm going to skip change of base because we're running out of time, and I wanted to get to some of the product rules. I'll fill that stuff in so that you can see it later. You don't need change of base for this particular homework, so we're okay. All right, so these are the rules for exponents, I'm sorry, for logs. They are the exact same rules as the exponent rules, because a log is just an exponent. So remember, over here, I'm going to do your exponent rules. Right? The first one is the product rule. If you have two things that have an exponent and you're multiplying, you add the exponents. It's the exact same thing with the log. I have log base A of m times n. I'm adding my exponent. So here's an example. If I have log base 5 of 3 times x, because it's multiplication, I can split it up and write log base 5 of 3 plus log base 5 of x. You just split it up. Whatever you're multiplying, you split it up and you put a plus sign. Exact same rule. I'm multiplying, so I'm adding. Exponent rules, I'm multiplying, so I'm adding. So now we have the same thing with division. So an example would be, say, log base 5 of 3 divided by x. Because it's division, so our exponent rule is the quotient rule, which says if I have x to the 5th divided by x squared, I subtract my exponents. Exact same rule. When I have division, I subtract it, and I'm literally just peeling it apart and just writing it individually. That's all I'm doing. Okay. And then the third exponent rule is your power rule. And this one says if I have x to the 3rd to the 5th, I multiply the two values, the two exponents. Oh, come on. So it equals x to the 15th. Well, same exact thing. So remember, a log is an exponent. So this is saying I have an exponent p on the log exponent. So all I'm going to do is I'm going to drop this p to the front, and now I'm multiplying. It's p times the exponent. So it's the exponent times the exponent. All right, so let me show you an example. Let's say I have log base 2 of x to the 3rd power. Okay, this right here, this log base 2 of x is an exponent. Logs are exponents. This 3 is an exponent on an exponent. So all I'm going to do is drop this to the front and multiply. And you're done. I have an exponent multiplied by an exponent. Okay, and then another way to write a log. So remember how if you have, x plus 3 raised to the 5th power equals x minus 1 raised, 2x minus 1 raised to the 5th power. If the exponents are the same, the bases are the same. Well, that's exactly what this one-to-one means. The exponents are the same, which means the bases are the same and the totals are the same. That's all that means. Okay, so an example of that would be, let's say we have log base 5 of 125 is log, I don't know what I wrote here. Oh, is log base 5 of 5 to the third. Okay, well, as long as my bases are the same, they're both base 5, that means my totals are the same. So as an exponent, if I have 2 raised to the 2x equals 2 raised to the, 4, then that means my exponents are equal. So that's what this is saying. As long as your bases are the same, the exponents are the same. Okay, so how do we solve these? So these are all just your general rules. And again, you'll see these. And in your My Math Lab, if you use the show me an example, it's going to show you these. So you will see these a lot. So what I want to do is, okay, so we're going to, I'm gonna jump up here because there's one that I want to show you that's that you will see in your My Math Lab. Okay, now here is the basic premise of being able to solve any log function. Okay, if it's given to you in log format, you want to rewrite it. So if it's in log format, you want to rewrite it as an exponent. That's the easiest way to solve it. So base 3 raised to the second power equals x plus 4. Now you guys know how to solve that, right? So when it's written in log form, rewrite it in exponent form. And now I can solve. 9 equals x plus 4, subtract 4 on both sides, and I get x equals 5. Okay, it was given to me in log format. I'm writing it in exponent format. So look at C. It's given to me in log format. I'm going to write it in exponential format. Right, so a log is an exponent. That's how I knew that one is an exponent. So 10 raised to the first power is 10. The x squared plus 5x plus 16 is your total. So I can subtract 10 from both sides and I get x squared plus 5x plus 6 equals 0. And now I can solve for x. What do I multiply to get 6? Add to get 5. Well, it's 2 and 3. So I have x plus 2. So this is going back to your factoring. So x is going to equal a -2 and x is going to equal a -3. Okay, so each one of them is going to look a little bit different, but if it's given to you in log format, set it up as an exponent, and then you can solve it, just like what you've been doing this whole semester. Okay, where it gets a little tricky is this is where you see how each one is written separately and there's a plus sign in between. So this is going back to your rules. Remember, with a log, a plus sign means multiply. So we can drop the logs and say x plus 2 times x equals 24. And then I can simplify. So what I'm doing is I'm taking it out of log form and I'm writing it in an equation form, because a plus sign means multiply. If I see a minus sign, that means I'm dividing. So I get 2x plus 3 divided by x minus 1 equals 2. And now I can solve, right? I multiply both sides by x minus 1. That cancels this. And then I have a straight equation. And now I can solve it. Okay, so this is where now you are jumping into, okay, I have algebra skills. Now I know how to solve this. I shouldn't have to show you how to solve this. You guys know how to solve this. You're going to distribute. And then you're going to go from there. Okay. All right, so it's given to you in log form. You're going to change it into exponential form, okay? When it's given to you in exponential form, okay, now it's in exponent form, you can rearrange it into log form. If you choose, you can decide how you want to solve it. But this is the difference now. Do you see how your exponent has the unknown? So that's where your logs come in. Anytime you have an unknown up in the exponent form, you can't solve it when it's in the exponent form. You have to drop it down. So I can, if I am, logs or ln's is an operation, just like adding, subtracting, multiplying, and dividing. So if I do the same operation to both sides of my equal sign, watch what happens. So I'm going to log both sides, or ln, you can do ln too. I'll do it both ways and you'll get the exact same answer. But what happens is, do you see how when I logged both sides, I now have an exponent on an exponent, which means I'm going to drop that exponent down. This is how you get it down into a straight equation. Okay, now I can solve. I just use algebra to solve. Now, this is where my math lab gets it a little bit confusing because they have you do it all in one step. And for whatever reason, calculators will calculate it differently, especially if you don't use parentheses. So you have to make sure that you do this one step at a time. Always one step at a time. Okay, so I want t by itself, right? That's my unknown. That's what I'm trying to solve for. So the first thing I'm going to do is divide off by this log. So now I have 12t equals, and I'm actually going to use my calculator. So this is why you have to have log on your calculator. I'm going to go log 2, close my parenthesis, divided by log 1.003, and close the parenthesis. So when you're doing these, when you're practicing these, I want you to make sure, that's a decimal, make sure that you do this one step at a time. Okay, so make sure that when you do log 2 divided by log 1.003, you get 231.3954608. Notice I'm not reducing yet. Never reduce until the very last step. So then I can divide both sides by 12. And I get 19.28295, which if I'm rounding to say 3 places, I get 19.283. And again, each question's different depending on how they want you to round it. Okay, so notice how they want you to round it. Okay. All right, and we're going to come back to this type of problem, but I wanted to throw in one more to you. So remember, radicals is the same as a fractional exponent. Oops, let me scroll up. So fractional exponent and rationals are the same thing. So remember, this is the setup of a radical, right? You have your radicand, which is your base. The index is the number, how many roots, square root, cube root, fourth root, and then to the exponent. And then these are just examples of a fractional exponent is a radical. So 4 to the 1/2 is the square root of 4. 8 to the 2/3 is the cube root of 8 squared. And you just do it one step at a time. So with this one, I would do the cube root of 8 is 2, and then squared is 4. Okay, so 2 squared is 4. So the k is one that you're going to see. So this is another example of your power rule, right? Now we're going in the opposite direction. So since we have the same base, right? Our bases are all the same, then we can pull it out and we're going to bring this back as an exponent. because it's an exponent on an exponent. So 25 to the 1/2. Addition means times. So we're going to multiply that. So again, we're going to pull this here. And we get 27 raised to the 2/3. And then subtraction means divide. So all of this divided by 15. Okay, all of it divided by 15. So here's the beauty of this. 25 to the 1/2 power is just the square root of 25, which is 5. 27 to the 2/3 power I did right here is the same as the cube root of 27, which is 3. 3 squared is 9. All divided by 15. So we have 45 divided by 15. So all of this gets broken down to x equals 3. Okay, so I brought this down. I rewrote this. I rewrote this. And I rewrote this. So just notice when you have a plus sign, it's multiplying. A subtraction sign is division. Same exact rules as the exponent rules. Okay, so this one, I wanted to put this one here because you do see this one in your My Math Lab. So I wanted to make sure that you had it. Okay. All right, last two things. So this is where knowing logs is different than exponential functions. Okay, we can solve for different things. So when you're looking at this, it says how many years. So we are looking for time. All right, we want to take the 6,000 that we started with, so that's our P, and we want to grow it to 9,400. That's our ending amount. Our rate is 6%. For A, we're compounding quarterly, so our N is 4, and for B, we're compounding continuously. So you have two different problems going on here. Same exact information. So for A, we're compounding quarterly. So our A is 9,400. Our principal is 6,000. Our rate is 0.06. Our N is 4, and we are looking for time. Okay, so we have our two formulas. A equals P, 1 plus R over N, raised to the NT, and then B is our continuous compound formula. Okay, so we're going to put all that information in. So in A, we have 9,400 equals 6,000 times 1 plus 0.06 over 4 raised to the 4, to the 4 times t. Okay, so notice your unknown, I'm going to write it in a different color. Your unknown is in your exponent position. Okay, that's what we're looking for. Where with the exponential functions, it was just straight, we were looking for A, or we were looking for P. It was just a straight equation. Now our unknown is in the exponent. So here's how I show this instead. That's different than My Math Lab. My Math Lab does it a little bit differently, and I don't really like how they do it. So this is much easier. First thing you're going to do, change my color. You're going to divide off the 6,000. Okay, you want to think about the fact that we're trying to peel everything off so we have t all by itself. So the first thing you're going to do is divide off the 6,000. So 9,400 divided by 6,000. And remember, you're not rounding anything. Don't round anything until the very end. Okay, that's our first step. Now I'm going to simplify within the parentheses. So I have to do the division first. Then I'm going to add 1. So I get 1.015 raised to the 4t. Okay, so all I did is I divided off the 6,000, simplified inside the parentheses, and now I have exactly what we did before. Except this time I'm going to ln both sides because I want you to see you can use either one. As long as you use the same operator or operation, it doesn't matter. Okay, you just have to make sure that you're using the same operation on both. So I have ln 1.566667. And remember, as soon as I put the operation of ln or natural log, this drops this down. So it's 4t times ln of 1.015. Okay, so what ln does is it creates an exponent on an exponent. So I can drop that exponent down. That's how you get it down into the straight equation. And now, again, unfortunately, my math lab shows you to do the whole thing. And I can't tell you how many times students get this wrong because they don't take it one step at a time. So I do ln 1.566667, close my parenthesis, that's super important, divided by ln 1.015, close the parenthesis. So I end up with 30.1539329. Again, I am not rounding anything. And then I can divide by 4. So my time is 7.538. And if we round to, one place value, it takes about 7.5 years to grow $6,000 up to $9,400 when my interest rate is at 6%. Okay, so this is my answer for A. So now that I have my answer for B, or for A, B should be very close to that. Okay, so I'm going to use the exact same information, except for now I'm doing it continuously. So I have 9,400 is my my ending amount. Beginning amount is 6,000. E, my rate is 6, and I am looking for time. Okay, continuous compound is actually much easier than the regular compound. So again, first step, divide everything by 6,000. Get rid of that. So 9,400 divided by 6,000 should be the same as what we had before. So 1.566667. And now all I have is E 0.06t. Okay, now it's just one step, right? If I ln both sides, look what happens. I get to cancel this, right? And because I ln'd both sides, I'm good to go. I've done the exact same thing on both sides, so I haven't changed the value of it. So what I end up with is ln of 1.566667 equals 0.06 times t. And now I can divide by 0.06. So my t is, so again, ln 1.566667. Make sure you close that parenthesis, divided by 0.06. And it's 7.4825. So again, if I rounded to my first place value, it would be 7.5. It's off just a little bit. It was 7.53 for regular compounding quarterly, and it's 7.48 with continuous. So it's a little bit less, but rounding it makes it close. So if your two answers aren't close, then you did something wrong. That's a real good indicator that something went terribly wrong. Okay, any questions on either of those? And we'll do one more with the continuous, because that's what you'll see in my math lab.
The two answers, they would have to round to be the same number, right?
Not necessarily, but they should be close. But so like if you did continuous and let's say you got 10.7 years, something's wrong. They need to be very, very close to each other.
Okay.
That's always one of those indicators, right?
Mm-hmm.
Okay, so here we go. This is our beginning amount. This is our ending amount. This is our rate, and we're using the continuous compound interest. Okay, so we have 10,700 equals 7,000 e to the 0.0525. So remember, your rate should always be a decimal. Okay. So your exponent is where your unknown is. So we're going to take our first step, getting rid of 7,000. So 10,700 divided by 7,000 gives me 1.528571429. And do not ever round until the very last step. I can't tell you how many students get really frustrated with my math lab because they do everything right. They do the process right, but they try to round it as they go. If you round as you go, that means what's happening is you're rounding and rounding and rounding and rounding. So you're skewing your answer. So don't round until the very end. Okay. All right. So again, variables in the exponent, don't like that. So I'm going to ln both sides, which lets me eliminate my e. And so what that did is it just dropped that exponent down. So I have ln 1.528571429 equals 0.0525 times t. So now I can divide by 0.0525. So ln 1.528571429, close my parenthesis, divided by 0.0525. So my time is 8.0825, so about 8.1 years. So to go from 7,000 to 10,700, it takes about 8 years to earn your money. And these are very accurate. These formulas are very, very accurate. Okay. All right. Any questions? You guys got it? Okay. So a few changes in our schedule. We're going to push. So this is after Thanksgiving. I'm gonna kind of see, because we only meet once next week. So we're only meeting Tuesday of next week. So I don't know how far we're gonna get into homework 18 and 19. The good news is homework 19, you already know it. It's the two formulas. It's these two formulas, the compound interest and the continuous compound. So that's why I think we'll be able to get through both 18 and 19 on Tuesday. We're definitely going to push homework 20 to after Thanksgiving. Okay. So that's next week. That's on Tuesday, but I'll let you know for sure on Tuesday which homeworks are going to be due the Monday after Thanksgiving. Okay. All right, guys, I will see you Tuesday. Have a good weekend. Stay safe out there, and let me know if you have any questions.
Based on all the what we went over like during class time, will we be able to go through all of the homeworks?
Yes.
Okay.
Yeah, you have all the information now.
Yes, ma'am. Thank you, miss. Have a great weekend.
Okay, you too.